In the last lesson, you wrote your first Swift code statements. In this lesson, you're going to learn how to group together code statements to perform a task. Now, these groupings of code statements are called functions. This is a very powerful concept because you can execute or call these functions whenever you want to perform that task. Let's dive in and see how we can write our first function. Okay, so first of all, how do you declare a brand new function? Now this is going to look somewhat similar to declaring a new variable or constant. It's a keyword followed by a name. So in this case of a function, the keyword to use is func, or func for short. And then followed by that, you put the name of the function. Now, just like a variable name, you are going to be referring to this function name in order to execute the contents of the function. Now, after the function name, you're going to have two rounded brackets. We're going to ignore these for now, but these two brackets, they are part of the name. And then following that, you have a set of curly brackets. And you're going to find most of the time in Swift, when you see a pair of curly brackets, it's code that goes in between those two brackets. In this case of a function, that is where we are going to put our grouping of code statements. So whatever code statements you want this function to run when you call it, you are going to put those code statements in between those two curly brackets. Okay, so let's put some code in there and see what it looks like. You probably remember these two lines of code from the previous lesson. If we put those two lines of code into our function and we change the name to say hello, it's going to look like this. Okay, so how do we call this function so that we can execute its code? We simply use the function's name, say hello, followed by the two rounded brackets, because that is also part of the function's name. Notice that we don't need to use the func keyword again because that was only for declaring a new function. So just like that, you are able to execute all of the code inside that function. Now, why don't we try it out in the Xcode playground so you can see it in action? So here I am with a brand new empty aside from the default code, Xcode playground. We have our var greeting equals hello playground string. And why don't we put in our second line, which is print greeting. And just like you saw in the previous lesson, when we run this, we are going to get that output in the playground right there. Now, let us declare a brand new function using the func keyword, followed by the function name, say hello, followed by two rounded brackets, followed by a pair of curly brackets. And oftentimes when you write these brackets, you'll find that Xcode helps you complete them. So let me just go back for a second. By holding Shift and hitting square bracket. So on my keyboard, that's how I get the curly brackets. Shift and do that. If I hit enter, it's automatically going to create a new line and it's going to create that closing bracket for me. In here, I am going to take these two lines of code. I'm going to press Command X to cut it and Command V to paste it in there. And let's run our playground and see what happens. So as expected, nothing happens because all we've done here is we've declared this function, say hello, and we've put in the code in between the brackets. It's not going to run this code unless we call the function. So if I start typing my function, this menu pops up. This is called an autocomplete menu, if I didn't mention that in the previous lesson. And this just helps you write code faster. You can just select it. It's Xcode being intelligent, right? So you could type this out if you want, but notice this is the function name, right? Followed by the two rounded brackets because that is part of the function name, and you'll soon find out why. Okay, but for now, let me run the code again and see what happens. Now this time I get the output in the console because this line of code is calling the function, which is executing the code in there. Now, if I call the function again, it's going to execute those two lines of code again. So you can see this is really powerful because oftentimes to perform a task, it's multiple lines of code working together to achieve a common result. And let's say there's 10, 20 lines of code. By putting it in a function, not only can you run that task whenever you want, but it also saves you from repeatedly writing the same code. And when you get to writing larger pieces of software, not repeating code is actually pretty important, because if you find an error in one instance of that repeated code, you don't have to go and fix it in all the other places you repeated that code. By putting it in a function once and calling it, from wherever you need to call it, you can edit the code and fix it from one place. Now that's pretty handy, right? If you like that, you'll be even more impressed with this next part. Now to take it a step further, functions can be even more useful because they can accept input into the function when you call it. And that is what the 2 rounded brackets is for, that comes after the function name. In between those 2 rounded brackets, you can put a series of what looks like variable declarations. If you take a look at this slide here, in between the 2 rounded brackets, I have m:string. Now what this is doing is declaring what's called a parameter for the function. This means that whenever I call the say hello function, I also need to supply the function a piece of string data. And then inside my function, within the 2 curly brackets, I can work with that piece of data, and I can reference that piece of data using the parameter name, which in this case is m. So you can imagine with this code now, whenever the say hello function is called, it also needs to be supplied with a piece of string data, which we can reference using m. And then within the function, we have the code print m. So in essence, this function serves the purpose of outputting or printing to the console whatever piece of string data you pass to the function. So let's try that out in the playground here. So instead of saying var greeting, I'm going to erase that line right there. And I'm going to declare a parameter of my function. Let's use m:string. This pretty much is a variable declaration, right? Except without the var keyword. But the proper terminology is this is a parameter of the function. You can only use m inside these 2 curly brackets. So we also need to modify our code here because there's no concept of what is a greeting now because we just deleted that variable. So let's print out m. And now you can see when we make these function calls, say hello, Xcode recognizes that, hey, if you were to call this function the way that you declared it, you need to supply a piece of string data. So it's saying it's missing the argument for parameter m in the call. So let's take a look at what that looks like. I'm going to erase those 2 function calls and I'm going to type it out again. Now, notice this time autocomplete detects that you need to supply a string data, and this is what that looks like. So I'm going to press enter. And this is where I would supply that piece of string data. And notice that it tells you this is going to be the parameter name. When you're building this for real, you would probably use a more descriptive parameter name than just m. So you might say message, for example, and it would make more sense as you're supplying the string data. But we'll leave it as m because to follow the example in the slide, I'm going to say I can code functions. Okay, let's run the code and see what happens. So as we expect, it prints out I can code functions because this piece of string data is being passed into the function as a parameter, and it can be referenced by this parameter label m, and then I am printing it out right there. I have a reference to m from within the curly brackets, but outside of the function declaration, it doesn't know what m is, right? If I try to print m like that, it cannot find m in this scope. This is called a scope. So you can think of the area between these 2 curly brackets as a standalone scope or standalone area. And only in that area does this parameter exist in there, that you can reference it using m. Now going back to our diagrams for a section, what does it look like to have multiple parameters for a function? Because oftentimes we may require multiple inputs. All it is simply is you declare your parameters separated by a comma. In this example, we have the same m parameter followed by a comma, and then an n parameter. Notice that this parameter data type is different. It's an int, so it expects integer data. Now, whenever we call say hello, we need to supply a piece of string data and a piece of integer data. Let's go back to the playground and try this out. So instead of modifying this function, I am going to declare a new one. And this one, let's say, does addition. And you haven't seen addition yet, so this will be interesting. So let's declare our first parameter a is an integer, followed by comma, so that I can declare the second parameter in this list, and it will be also an int, and I'll call that b. Okay, and then I have the opening curly bracket. I hit enter, it fills in the closing curly bracket, and inside here I am going to put the code. And what I'm going to do in here is I'm going to add up a and b and then print it out to the console. So I'm going to say var sum equals a plus b, and then I'm going to print out the sum. So you should be able to recognize this code. Var is declaring a new variable named sum. Equal is assigning this, the right hand side, to the variable sum. And this plus symbol, as you can guess, adds two integers together. So we just have a plus b. But a and b are parameters that get passed in to this function call. All right, so let's try this out. I'm going to call this function doAdd, and Xcode finds it on the menu. So I'm just going to hit enter to auto-complete that. And all I have to do now is fill in the two integers that I need to pass in. So let's say 2 and 3. Let's run the code, see what happens. As expected, it prints out 5. So that is an example of providing single inputs and multiple inputs into a function. Now let us go back to the slides and extend it even more. Now functions can be made even better because functions have the ability to return output when you call them. Let's take a look at how this looks like. If you look at this syntax, notice that after the function name, after the rounded brackets, we have a dash followed by a greater than sign, which makes it look like an arrow, right? In fact, that is to signify that this function returns something, like it produces some sort of output. And then followed by that makeshift arrow, we have the data type of the data that this function produces. In this case, I'm going to put int because I want to return or output a sum. And then within the curly brackets of the function, you have to make sure that you have the return keyword, because if you've specified that this function is going to produce some sort of output, then you have to use that return keyword and actually produce the output that this function returns. And you also have to make sure that what you are returning, the output data, matches the data type that you have said this function will return. In this case, I've indicated that doAdd will return an int data, and inside the body of my function, I'm returning a piece of int data. So all is well. Now, before we go into Xcode Playgrounds to try this out, let's combine this with input parameters and see what that looks like. So if you take a look at this slide, I have two input parameters, a and b. They're both integer types. They're separated by a comma in this parameter list. And then after the rounded brackets, I have that arrow, and I am specifying that I'm going to be returning an int data. In the body of my function, I am adding up the two inputs into a variable called sum. And then I have the return keyword, and I'm returning that sum as an output of the function. Let's take a look at this in action in our playground. So let's modify our doAdd function here. I'm going to put a space after the rounded brackets. I am going to hit dash greater than space, and then I'm going to say that this returns int data. Now Xcode is going to complain here because it detects that I've indicated I should return int data, but I'm missing the return keyword for an expected int data. So instead of printing this out, I'm actually going to say return sum, just like in our slides. Now let's run this code and see what happens. Notice here that I am calling that doAdd function, and I'm passing in 2 and 3 as my input parameters. Now there is no output. Nothing pops out in the console. Why is that? Because we don't actually have a print statement that outputs it to the console. You might argue, but we're returning the data from here. Well, returning the data doesn't mean printing it out. Returning the data means that this function produces that output. But where does it go? Well, what we have to do is we have to declare either a constant or variable to refer to that output. So here's what we're going to do. I'm going to declare a constant this time. I'm going to say let result equals the output of do add. Right? So what's going to happen here when I execute this function and it produces that sum and it returns it, that output is going to get assigned to my constant result. If I run it right now, there also is no output. Well, why is that? Because in this line of code, I've merely kept track of the sum. So now I can refer to that piece of data. I still, at the end of the day, need to print it out. So I'm going to write print result here. Now I did this so I can illustrate to you how it's different printing it inside the function versus returning it out of the function and then capturing it, capturing a reference to it with a constant or a variable and then working with it. Now, you might say that's redundant. I could have printed it inside the function, and that's true. But I mean, this is a really small scenario, right? This is important because sometimes you may need the output to further work with it, maybe you might want to pass that result into a second function. You might want to work with it in some way, not just simply print it out, right? With the ability to take input and to produce output, functions can truly live up to their name and help us group together sets of instructions. Now, there are a couple more things I want to show you about functions before we are done with them. One is called a parameter label. So when we declared parameters here for our do add function, what we could have also done right before the parameter name, you can put a label. So you can say, let's say first num, and before parameter b, you could do the same thing. You could put another label, second num. Let's take a look at what that does to our function call. Now I am going to erase this line of code here, and we're going to type do add. And this time, take a look at what autocomplete suggests for us. It is now using the parameter labels instead of the actual parameter names. It functionally, the function works exactly the same way. So if I put 3 and 8 here, and then I run the function, it's going to output 8. The only difference now is by putting these parameter labels in front of the parameter names, it is going to change how you call the function. The reason for doing this, there may be multiple reasons, right? One could be you want words that are more descriptive so that when you're calling your function, you remember what data you are supplying for it. This also allows you to, notice inside your function, you are still referencing them by the parameter names itself. So that's something you can use to make your functions a little more intuitive as you're reading them and using them. Something else you can do is if you don't want to have these at all, right? If you don't want to put labels or parameter names at all, you can replace your parameter labels with a simple underscore. You can do this with one, you can do this with both, it doesn't matter. Let me just do it for both and show you what that looks like. So I'm going to type do add again, and this time take a look at what it shows up as. So you'll still see that parameter name here, but when you're now adding your data, notice that you don't see any parameter names in the function call. You also don't see any parameter labels in the function call. So this might be good for very intuitive function names. So do add, you pass in 2 numbers, very obvious what that's going to do. Or it could be to shorten the function calls itself, or things like that. And the last thing I want to mention to you is what is a function signature. And just like a written signature, a function signature is used to identify a function. And that consists of the function name as well as its parameter list, including argument labels and such. It may seem pretty obvious, but let me introduce a scenario to you. So if I have another function called doAdd, and this is going to be that, right? And maybe this is, I don't know, maybe A plus B plus B, and then return the sum. So obviously the calculations are a little bit different, like what each function does, but they're both called doAdd, and they both have parameters A and B. So what is the function signature? Well, the function signature of this one up here, doAdd, is that, and the function signature of this one is this, right? Like this one is this, and this one is this. So they're different, and it is a combination of function name, like how you are using those parameter labels, plus the parameter names itself, if that is even a factor. Now, in terms of the topics covered today, I would say declaring functions, function inputs and outputs are the most important thing. Parameter labels and function signatures are nice to know, especially when you get to reading Swift code and you won't get confused about why some things look the way that they do. But yeah, all of that combined is a good working knowledge of Swift functions. I hope that with these two lessons, you're starting to realize that coding is completely within reach for you. Now, if you're learning a lot from these lessons, please give this video a thumbs up and don't forget to subscribe so you don't miss the next lesson. Now, with functions under our belt, we are able to execute a batch of code to change the cards up top when the user taps on the deal button. And you're going to learn that in the next lesson. I'll see you there.